let's talk through a little equation solving strategy. So you're used to seeing exponential equations like, I don't know, maybe this. And the idea is you want to isolate the term with the x so that you can undo it. So we would have 2 to the x is 16. Oh, I guess this one came out quite obviously. So you know what power... Well, I mean, let's pretend that we don't remember this and let's do it like you would do it algebraically. So if I want to undo an exponential, I do log base 2 of 2 to the x is 16. So these undo each other, and I'd have, is log base 2 of 16. So I'd have x is log base 2 of 16. But this is like a helpful reminder about what logarithms tell you. Log base 2 of 16 is what power of 2 equals 16. And you know what power of 2 equals 16. The answer is 4. And that makes sense over here. You wouldn't really have needed to do this if you just thought about it, because 2 to the 4th clearly is 16. Okay, so this kind of thing works great as long as you can have a single term with your x in it, so that way you can get everything to the other side, so that way you can undo the exponential. What if you've got something like this? Here I've got two different terms with an x in the exponent. Well, what if I could make it look like this? What if I could get the base of both sides to be the same? We've got some number to a power equals that same number to a different power. So if these two sides are equal and the base is the same, then that implies that the exponents have to be the same. At least as long as the base doesn't equal 1, because like 1 to the anything is 1. So if we can manipulate this so that the base on both sides is the same, then you can set the exponents equal, and now you're up and away. So could we do it? Well, what I'm noticing is that both of these bases are powers of 3. So here I've got 3 to the 3rd power is 27, and here I've got 3 squared is 9. You can apply your exponential simplification rule, where this is going to be the same as 3 times x in the exponent. And this is going to be the same thing as 2 times 3 minus x, so that's 6 minus 2x. Okay, so far so good. The problem is we've got this pesky 2 here. I can't just set the exponents equal. I can't say 3x equals 6 minus 2x. Because that wouldn't make any sense, because we have this extra 2. So let's keep simplifying. What I know is that if I have like 3 to the a over 3 to the b, that's 3 to the a minus b. So what I'm thinking is let's divide both sides by this, so that way we can hopefully combine the exponential terms into a single term. So here I've got 3 to the 3x divided by 3 to the 6 minus 2x equals 2. And now I can simplify the left-hand side here as 3 to the 3x minus 6 minus 2x equals 2. Okay, great. So it looks like we're not going to set exponents equal after all. We're going to take the log base 3 of both sides so that we can undo that exponential. So I've got 3x. Let's distribute the negative sign here. Minus 6 plus 2x equals log base 3 of 2. Log base 3 of 2 is just a number, so you can just think about this as being a single value. And now we're up and away. We've got 5x minus 6 equals the log, which means 5x equals the log plus 6, which means x equals the log, which I'm now going to rewrite, plus 6 divided by 5. And this is like a perfectly great answer. Each of these things is a number, and so the overall thing is a number. Okay, so just go back and review. What were the major strategies that we used here? We figured out that you can write the exponential terms using the same base. Then we tried to do whatever we could to combine those terms with the same base together as one term. And in this particular case, we realized that dividing would let us simplify it. And then once we had the exponential term isolated, we could undo. Okay, why don't you see if you can apply a similar strategy to this one? Think about what could you do that would let you get rid of the exponents, or rather get rid of the exponential terms. All right, so what I'm seeing is 25 is 5 squared. So then I can apply the simplification rule, where that's the same as 5 to the 2x. And now I've got 5 to the x squared minus 3 equals 5 to the 2x. So because the bases are the same and the overall values on either side are the same, that means the exponents must be the same. So I'll set them equal to each other. And now it seems like I've got a nice quadratic which I can solve. So what's this? This is x minus 3x plus 1. Does that make sense? Yeah. So we've got x is either 3 or negative 1.